For the rational function we see here, we find the zeros of the numerator, and we simply set this factor equal to 0 and solve, we get x equals 2 and 3. Set this factor equal to 0 and solve, we get x equals 4, negative 4. That immediately gives us 1, 2, 3, 4 points on the graph, corresponding to the 0 at x equals 4, x equals 3, x equals 2, and x equals negative 4. The denominator set equal to 0, we have solutions x equals negative 1, x equals negative 6, and the zeros of the denominator give us vertical asymptotes. So x equals negative 1, we have a vertical dotted line here. X equals negative 6, we have a vertical dotted line here. The end behavior, for large absolute value of x, only the leading term of the numerator and the leading term of the denominator have any influence. And for the numerator, if we multiply this out, the leading term will be x squared. Leading term of the denominator, leading term of the numerator will be x squared times x squared, x to the fourth. Leading term of the denominator will be x squared. So that for large absolute value of x, y acts like x to the fourth over x squared, which is just x squared. As x approaches plus infinity, then y approaches infinity, and as x approaches negative infinity, y still approaches infinity, because when you square a large negative number, you get a very large positive number. On the whole, this graph, as far as its end behavior, is going to act a lot like a parabola. But in between, near the vertex, we get all this behavior, which is explained easily enough. We've got to go up to get to the, as we go to the left, we get large positive numbers, so the graph goes off and approaches infinity. For large positive x, same thing. So the graph has to come down from large values here, it has to exit through large values here. We also get a y-intercept of 0, negative 16, easily found by substituting x equals 0. So our graph has to start up here. It can't go through the x-axis because there are no zeros over here, so it has to turn around and come back up to form its asymptote here. And then, since the x equals 4, negative 4 asymptote was obtained from basically a linear factor, we have to change signs, and we have to come down here, up through the 0 here, leaving us where we can't get back through the x-axis. We have to go up to a positive, to an asymptote through positive values. Then, to get through the 0, to get through the y-intercept at negative 16, there are no zeros between here and here, so we got to start from large negative values, come up through this point, then we go through our 3 zeros and back up on the right.